All right, good morning and welcome back. Today we are going to be talking about the unit circle. So this is very foundational for this chapter and even this whole semester of trigonometry. So we want to make sure we get a lot out of this and really learn it good during this first week, so that way we kind of can understand it throughout the rest of the semester. Just a couple of reminders. Some of you, second half of the alphabet, you're watching this on Monday. If you want the notes, go to resources, go to chapter 6, scroll down here to 2/1. That's our date. There's a blank unit circle here. You can download, open up, print if you want to. I will be giving you these notes on Wednesday as well. So if you'd rather just kind of follow along and watch, that is fine. Please watch through the video though. Those of you who were at school on Monday, you're now watching this on Wednesday, getting your second time at it. The reason we're going through it twice is just it's pretty important conceptually for this whole semester. I want you to really understand it. So go ahead and if you have these notes, follow along. If not, just watch and we'll get you caught up soon. So our unit circle, I'm actually going to go ahead and close this video so that I have some more space here. But our unit circle here, we have a couple different things on it as pointed out up here. So degrees and radians go inside our circle. So you'll notice here's the degree sign. Here's a blank spot. That's where our radians go. And then the values go outside the circle. Now the values are like coordinate points out here. And I don't want to get ahead of myself, so let's just go ahead and start with degrees. Now, our unit circle is a circle here that always starts on the right side and moves around in this direction. It moves around counterclockwise, okay? Much like we started last semester, we started covering some of this. So you know that it starts at 0 degrees. So 0 degrees here. And as you can see, there's kind of some big jumps, some small jumps. Now, we know up here that's 90 degrees. You guys already know that's a quarter turn. We know that a half turn is 180 degrees. You know, 3/4 of a turn, 270 degrees. Now, each time there's a big jump like this, that will be a change in 30 degrees. So 30 degrees, but then here, you see there's a small jump. That's going to be 15 degrees. So 30 plus 15 gives us 45. 45 plus 15 gives us 60. 60 degrees. Okay. Now another big jump. 60 plus 30 gives us to 90. 90 plus 30, 120. Okay. So as we go, then it's a small jump. So plus 15. So 135 plus 15 goes to 150. Then we have a big jump to 180. Another big jump to 210. Small jump here, so just 15, so 225, plus another 15 for the small jump, puts it at 240, plus 30 for the big jump, 270, plus 30 gives us to 300. We're almost done, plus 15, plus 15, plus 30 on the final one gives us 360. That's one full rotation around this circle. Okay, and many of you probably already knew that. Okay, now remember radians. When we talked about radians last semester, if we would like lay down the radius around the outside, radians are another way to measure this angle in here. It's kind of like degrees, just converted. Much like inches and centimeters are two different ways to measure length. Degrees and radians are two different ways to measure our central angle in here. Okay, so once again, it starts at 0, and I'll do this in different colors. So let's see, I'll do this in red. So 0 radians. Now, for this first one, 30 degrees becomes how many radians? You might recall last semester when we had 30 degrees, we could convert that to radians. The way we do that, we'd multiply it by pi divided by 180 degrees. Okay. Now our pi's would cancel, our degrees cancel. The 0 here cancels. They're both divisible by 10. 3 goes into 3 one time. So we'll just be left with pi on top. 3 goes into 18 6 times. And right here, pi over 6 is what we would get. Okay, and so that is how many radians 30 degrees is. Now, if we wanted to, let me rewrite that, pi over 6. So if we wanted to, we could go ahead and calculate every one of these. So for the next one, 45 degrees, we do the same exact thing. 45 degrees, to get it to radians, we multiply it by pi, divide by 180 degrees. And once again, degrees cancels, degrees cancel. Now here, 45 goes into 45 one time, so we're left with just pi on top. It goes into 180 4 times. We're left with pi over 4. Now here's the thing. This would be pretty tedious to do these for all of these spots. So while it is true we could do that, I am going to go ahead and fill them in. We have this unit circle. It's already been done for us. We don't need to spend the time right now doing that. If you don't trust any of these, feel free, go calculate it yourself. You can figure it out. If you have any questions, please let me know. But we're going to go ahead and just fill things in. So pi over 3. Okay, up here we have our pi over 2. Then we start around the other side. So 2 pi over 3. And at 135, 3 pi over 4. Let's see, we got 5 pi over 6. Now over here you might notice at 180 it's just pi, which hopefully that makes sense because you might recall from last semester we know the whole circle is 2 pi radians. Down here, 210, 7 pi over 6, then 5 pi over 4, and 4 pi over 3. At the bottom, we'll get 3 pi over 2. And then we start working our way around the other side here. 5 pi over 3. 7 pi over 4. 11 pi over 6. And our final one here, 360 degrees, one full rotation is the same as 2 pi radians. Now, as we go, you'll get more and more familiar with this. I'll teach you guys some tricks to help it maybe be a little easier to recall these. Also, keep this paper handy. You'll be able to reference these whenever you need it. But it does get easier. The more comfortable you are with the unit circle, the easier this semester will be. So I recommend this first week, even memorize it. If that'll be the most helpful, okay? You should know this very, very well. If you know it very well, I think you will do better in this class than those of you who do not know. Now, over here on the outside, you'll notice there's these ordered pairs that we're waiting to fill in our x and y values for. Now, some of you might be wondering, what exactly is this unit circle? So once again, the unit circle is just a circle centered around the origin. So this point in the middle is the origin. And it is such that the radius is 1, a length of 1. So if we look at this picture here, like on the coordinate plane here, and this pink circle matches up here, so you know all the way to the right is at the point 1, 0, straight up is at the point 0, 1, to the left, negative 1, 0, straight down is 0, negative 1. And then all the points are somewhere in between there. Okay, so if we fill that in, let's see, I'll go ahead and do that. It's purple here. So right here on the right side, we have the point 1, 0. Up at the top, the point 0, 1. On the left here, we have negative 1, 0. And finally, at the bottom, we have the point 0, negative 1. Okay. Now, as you can see in this picture, all these other points, they're not going to be whole numbers. They're somewhere in between. And we could use decimals, but we want to be as precise as possible. So we're going to use fractions. We're going to use radicals. We're going to make this as precise as possible instead of using our decimals. So as we fill this in, and what I'm about to do, I don't recommend you draw on your shape. You can just watch along as I do it. But if we think about it, at 30 degrees, the point that we're writing in here is this point right here. So we're saying that point occurs, and the angle formed here, the central angle, is 30 degrees. Now if we think about it, if we had a triangle that connected from the radius out, and then our hypotenuse here, now we know that hypotenuse is the radius right here. That would have a length of 1. Now this is a 30, 60, 90 triangle, and back in geometry we proved what this was. Now you can take our word for it. You don't have to prove it. If you'd like to understand why, definitely let me know, and I'd be happy to go over these again with you, explain to you the concept. But we did learn this in geometry, so we're going to kind of brush over it. But in our 30, 60, 90 triangle, we know that the length out here, this would be like our x distance, and that is adjacent to that 30, and that will be represented here with square root of 3. Let me switch back so you can see it a little better. So square root of 3 over 2. And meanwhile, this length right here is just 1/2. Okay, so once again, we proved that during geometry. If you'd like to talk more about that, let me know. I'd be happy to go over that with you. Now, our second triangle. Once again, I don't recommend you draw this, but if you wanted to, we're trying to get to 45 degrees here. So right here, we would draw this triangle in. Once again, our hypotenuse is still 1. You might recall in geometry, we also had the 45, 45, 90 triangle. Now, if this is 45 and this is 90, we know this angle is also 45, which means these two have to be the same length. So that means our x and our y are going to be consistent. They're going to be the same. And in our case, if the radius is 1, if the hypotenuse is 1, it would be square root of 2 over 2, square root of 2 over 2. Now, this third triangle we're going to have is actually the same triangle we already had. Now the difference is, this time the angle here is 60 degrees, but if we think about it, if this is 60, we know every triangle in the world adds up to 180. Here's 90 and 60, that's 150, which leaves us with 30 degrees for up here. So it's the same triangle that we had drawn over here, just oriented differently, which means our x and our y value will flip. Okay, so instead of square root of 3 over 2, it becomes 1/2, and likewise the second one will become square root of 3 over 2. Now, we could continue with this logic all the way around, but keep in mind, we know that this is proportional. We already figured out the gaps are the same. So as we do this, if we think about it, when we have our coordinate plane, this is our y-axis, this is our x-axis. Hopefully you know that x is positive to the right, negative to the left, y is positive up, negative down. So up here in quadrant 1, this first quadrant, all of these are positive, both your x and your y's. When we move over to quadrant 2 here, this point will reflect over here. It's going to be the same values, except the x, instead of positive, will switch to negative. Okay, so if we think about it, it will be negative 1/2, and then square root of 3 over 2. The y's will stay exactly the same, because it's still above the x-axis. So we fill those in. The only difference is our x becomes negative. Okay, now quadrant 3 down here, this time both of them will become negative. Because we are left and down. So as we fill this in, then our final quadrant, quadrant 4, this is where x is positive once again, but y is negative. So down here, it'll be just like these, except x will once again become positive. All right. So as we look at our unit circle, we've filled in a lot already. A couple things I wanted to point out still. As we said, up here, you might want to make a note. This is our quadrant 1, quadrant 2, quadrant 3, quadrant 4 to the bottom and the right. Now you might also want to point out, so we have quadrant 1, 2, 3, and 4. Sometimes those are written in Roman numerals. So if you see this, I'm guessing you are familiar with Roman numerals by now, but 1, 2, 3, and 4, all of them are pretty self-explanatory, except maybe 4 if you forgot IV. Sometimes it might not have the lines above it, so it might just be 1, 2, 3, 4. So that's something to keep in mind. Now we're almost done here. I know we've learned a lot today, but the final thing I want to wrap up with, we're going to list the definitions of our 6 trig functions here in terms of our x and our y value. So these x and y, if we think about it, if we had a right angle here, okay, so those triangles we were drawing were right angles, and compared to our central angle, we could find our sine or our cosine. So our sine, so jot this down to the bottom. Our sine is, and we are going to treat it, remember sine is so O over H. Now if we had, once again, you don't need to draw this, but if we had this triangle here, compared to this angle, we said the opposite, so that'd be over here. That'd be our y value, and our hypotenuse is on top. So it'd be y over our hypotenuse, which is the same as our radius, y over r. And we know on the unit circle, the radius is 1. So anything over 1 is just whatever was on top. So our sine is y. Likewise, cosine is the same idea, except it's adjacent. So cosine will be x. And that leaves us with just tangent then. So tangent, TOA, still y over x. Now, keep in mind, we also have the other ones, the reciprocals. So our cosecant, that is the reciprocal of sine. So instead of y over 1, it becomes 1 over y. Our secant matches up with cosine. So instead of x over 1, it becomes 1 over x. And finally, our cotangent matches up with tangent. So instead of y over x, it becomes x over y. So right here, these 3 sets, you might want to put arrows between them. Those are always reciprocals. Kind of think of them as going together. Sine and cosecant are the reciprocals of one another. Cosine and secant, reciprocals. Tangent and cotangent, reciprocals. Okay, so I know we had a lot of information today. There is its learning assignment as we kind of analyze this. So watch this video as many times as you want. If you're in the Monday, Tuesday group at home and you don't feel ready to solve the problems yet, you can and wait until Wednesday. We're going to go over this again in class, and then you can try it from there. But go ahead, give it a try, and if you need any help, please reach out. Hope you guys have a great day, and I'll see you guys soon.